Three, two, one, go, and we're live. Hello, everybody. This is a live stream about plugin development and especially about a very new topic about migrating the plugins to the K2 mode. This session is recorded, of course, and it will be interesting to hear your feedback later. Was it informative? Was it like presented enough information, and will it be enough for you to migrate your plugins? My name is Anton. I'm the host today. Today with me, I have two experts on the plugin development and Kotlin altogether, two in one, one in two. Dmitry and Anna. Please welcome the folks. Here they are. And Dmitry is going to tell us about the new analysis API for Kotlin, and which is meant to replace the old API in plugins for working with Kotlin code. And Anna is going to show us a very awesome demo of migrating an existing plugin from the old API to a new one. As the stream goes, that it's live, but if you're watching it in the recording, don't hesitate to ask the questions either in the comments to the video or in the platform Slack. We will have a link in the description. So without further ado, I would like to welcome Dmitry and give the stage to you and tell us about the new API that we have for plugin developers.
Thank you, and hi. So let's start with presentation about migrating Kotlin plugins to Qt mode. And the first question, should I migrate to your plugin or not? And the answer mainly depends on your dependencies. So let's take a look on a few options. And option one is your plugin do not have any Kotlin dependency, like to the Kotlin plugin. And in this case, migration is not needed. And of course, the case with direct dependency, when your plugin has dependency on Kotlin plugin. In this case, migration may be needed. And the last option, you have a transitive dependency on the Kotlin plugin. In this case, migration for your plugin is not needed, but compatibility is fully depend on your third-party plugin. And if it is compatible, your plugin is compatible as well. So let's now look a bit on what is the same for Key 1 and Key 2. And both of them share the same syntax, also named as Kotlin PSI syntax tree. And you may know it by Qt prefixes. And with code example, you might check like it's a regular function, like you have Qt name declaration, which represents, for instance, property, function, or class with name. And we want to return a new infinite for it. So our declaration has name, which basically returns just a string, and we return it with some random integer. And later this name, for instance, can be used for refactoring or something else. And now let's take a look on the interaction between compiler and the IntelliJ plugin. In Key 1, it's pretty simple. Kotlin plugin directly uses the compiler and uses everything that it can, any internal stuff and so on. And in Key 1, in Key 2, we have analysis API as a bridge between the IntelliJ plugin and the compiler. In this case, Kotlin IntelliJ plugin cannot use anything which is internal in the compiler and only can use the analysis API. So what's the difference? The difference is semantic. So in Key 1, you may know such things as declaration descriptor or Kotlin type. And basically, semantics means that it contains information which is not just available in text. For instance, you may have type or even implicit type, and just from text, it's impossible to understand which fully qualified name it has. For instance, in key1, we may have a function like hasInt return type, and it accepts function key_named function and just a regular function with name. And here we have a well-known way to jump into the descriptor worlds, like resolve to descriptor f_any. In this case, it will return function descriptor, which represents some information about this declaration, like visibility, like public or private modality, and so on. So the compiler know about it more than just text. And we can use return type to return a Kotlin type, which represents the type. And definitely we can check if it's Boolean or not. On the other hand, we have K2, and here we have similar concepts like K_symbol and K_type. And for convenience, all classes in the Analyst API have K prefix. And the same example can be written pretty the same way. But the difference is that in K2, we have analyze block, which is the entry point to the Analyst API. And inside, we have dot symbol, which is basically a jump from PSI world to the Analyst API world. And then we can just call the same way return type, which will return type representation and some extension function with checks if it's type integer or not.
Dmitry, can
Yes.
I ask a stupid question right at this slide? So the descriptor, as you said, doesn't contain or does contain more information that we can see in the text. Does it mean that, let's say, for a simple example like a single expression function where we infer the return type, that will be populated into a descriptor?
Yes, that's correct. In this case, the compiler will infer this type.
Perfect. Thank you.
So yeah, and here's the question: why is Analyst API? So which problems we had? And before K2, definitely there will no public API. So no any compatibility guarantees, as I said before. So the plugin, for instance, IntelliJ plugin just called everything it can from the compiler, and it can be broken at any time. And because of it, definitely there were no any documentation, just because it's internal API. And there were no any caching. So the user was responsible for implementation and maintenance it and some invalidations. And because of it, the resolution API was split between the compiler and the IntelliJ plugin. So a lot of resolution things in Key1 were like some wrappers on the plugin side. And definitely, it's easy to have memory leakages. As an example before, we may have just descriptor, and you can easily return it from a function, and that's it. Basically, at this point, you already may have a big memory leak because descriptor basically holds all the compiler world and a lot of memory. And with Key2, we have public API. So the Analyst API offers both source and binary backward compatibility for its stable parts, and it's well documented. So almost all stable APIs have meaningful key docs, and we even have dedicated guides, and we will improve everything in the future, sure. And Analyst API provides built-in caches, so the user shouldn't really care how to cache something or not, because everything is cached out of the box. And Analyst API provides such thing as lifetime owner interface, which limits the lifetime to the analyze block, which helps us to prevent memory leakages. And the main entry point to the Analyst API, as already shown, it's analyze block. And what does it mean? It helps us to jump into the block where we have K session. And basically, K session is its entry point. It contains all utilities and helper functions to get some semantic information. And if you want to propagate key session to your some functions, our recommendation is to use either receiver parameters, or you can pass it as a regular parameter and then use just this session as on a second example. And now it's time for demo. Anna, please.
Oh, exciting.
Hey, thank you, Dima. Today we will try to migrate a very popular IntelliJ plugin, code test. We are very thankful for its author, Sam, who is the long maintainer of the plugin, and he allowed us to show this plugin today. And from the start, I will show you the guide, and we will try to start locally with K2 mode. So let's copy this and paste it into the.
Anna, can you make it full screen, please?
Oh.
Yeah, so that we can see more code.
I would navigate to the code, but okay. So let's paste what we wrote in the guide, and when we start this, we will get the ID which will be in the K2 mode already. And as expected, we get the notification that the plugin is not compatible with K2 mode. And indeed, in my very simple example, there are no gutters, and I can't start test. There are no menus, but yes, it's incompatible. Let's try to do it compatible and go back to the guide. It says that in order to make the plugin compatible, we need to add these extensions. Let's copy. Let's find our plugin XML. It must be somewhere here. So we already have extension stack, but it contains another namespace, IntelliJ, and our tag is here. So we can just paste it right here. As you see, there are red code. It won't be there a little bit later when we update everything. And let's restart and see what will happen. So I would expect that there would be a lot of exceptions. No, there are no exceptions, but the plugin is available. Let's check. Yeah, the plugin is here. It's not marked as incompatible. So it must be something interesting inside. Probably everything is fine, but we don't have our run gutters. So we need to find out which API we need to migrate. In order to do that, I'll try to analyze dependencies on the whole project and see which code our plugin uses from the Kotlin plugin. I'm interested now in production classes only, and here I'm interested not in IntelliJ Java plugin or IntelliJ Lang. I want to know only details of the Kotlin plugin. Let's see, there are a lot of different packages, but we are mostly interested in this package with resolve name. And let's navigate what it is. Indeed, everything is red. The code compiles, but we marked this code as deprecated and scheduled for removal. This is the entry point for K1 analysis. Okay, but why haven't it failed? Yes, we have this run catching, which just catched all the exceptions which we hoped to see. And let's just remove this catching and see if it will help. I'll call unwrap just to ensure that there is no catching anymore. This catching should be done actually by the platform itself, and it should process everything. Let's try. Now we hope that we will get exceptions instead of run gutters. Oh, yes. This is not our exception, but this one is exception which you will probably see if you will try to migrate your code first. This one is a class from the K1 API, and it's not available in K2 mode. All good, what we expected. So my suggestion would be to refactor this code and see if we can make it work with K1 and K2 mode at once. What I see here is that we try to make the FQN from the parts, but there is actually a good method to do it, and it will just help us to get rid of this part completely. And later on, we try to ignore Kotlin API from our hierarchy. That's understandable and that's good, but let's try to do it a little bit in another way. Let's extract class ID, and let's take this class ID only if it's not any. There is a utility class with different class IDs, and it contains also any. So we just migrated this part. Don't need it anymore. What do we have here? Here we return the type. Let's extract the name, and let's rename here what we have here. We have super types list of the extents and implements. Then we try to have type references from this list, and then we try to get actual type from that Kotlin type. Okay, let's try to do it in one action. I'll do it in this hacky way, and then we don't need this anymore. Let's keep it for a while. This type is nullable, but let's keep it. We want to flat these two calls as well. And we will do this as suggested. But instead of keeping this here, we will just replace with what we already have here. And after that, we need to get rid of additional type parameters. And actually, this code works. And for K1 mode, it's okay. It should be equivalent to the code which was printed here before, just in slightly different manner. It's very uncommon, I would say, and it surprised me in a positive way that there are tests. Let's run them and hope that they will pass. Seems that everything goes right. Okay, nice. We will go to the test. We will return to the test a little bit later. But now we will try to use K2 API actually, because before that we just resort things out. As Dima said, we will need the entry point for analysis. And this one would be analyze method. Here it's a little bit complicated because there are two different analyze methods. I will use this one, and it will insert this fully qualified name because yes, it's the same name in both K1 and K2. We will start the analysis from the class, our class. And now we will need to find here we have the type reference. Let's rename this in order not to make some stupid mistakes. So this reference is an expression, and in K2, we can just calculate its type like type. This type is not Kotlin type anymore. It's KA type. Let's have it. This KA type, we did this line. And now we will proceed here. This K type also has all super types. We don't need any approximation. Doesn't even matter what it does. Here we will wrap in parentheses. And now we will just need to do map not now. Let's keep the type which was suggested. And this type actually can have a symbol inside, and this symbol has class ID. This is this part. So we can just copy paste the rest. Restore what we had and just remove. Now let's try to check if it works. And after that, we will go to our tests. Oh, exception is inaccessible. So I made some mistake. Let's check. So looks like that I analyzed something outside the analyze context. Let's try to do this way. I called the analysis session with the sequence, and thus I get some troubles. Okay, nice. So I have these test gutters now, and I can actually run this test. It will think and then run. And we will go back and try to run our tests, which we run initially with the initial implementation. Those tests are still run over K1, but it uses the same analysis API which we use for K2. And they are failing. And this is a typical failure. Initially, the plugin is allowed to call resolve or some other heavier process on EDT, event dispatch thread. But the K2 mod tries to help you to find such cases and to make sure that you don't do this. And if you do this, then it will throw an exception, and you can wrap this exception that you know what you are doing or try to fix. I will try to fix the first test, and then we will continue. So this test inherits from light Java code inside text fixture, and it is actually called on EDT. To avoid this, we can try to overwrite run in dispatch thread method and just return false. If we rerun this test, it should fail, but fail differently. it should tell us that we started something outside of redaction. It means that anything can be changed at any point. So let's just obey and wrap everything inside in redaction. I will do it in surround with manner and then try to find some redaction. And try to restart. Here we are. So we fixed the test because all the code which is called from the plugin in the platform is called actually from background threads. So we don't need to show any progress or do anything. We just need to ensure that the tests are testing as close to the production as we can. So we need to proceed with all other tests. They are failing in the similar manner, but actually we are not done yet. This plugin has a lot of compatible versions, starting from 22.3 until 24.2. And unfortunately, there is no analysis API available for the older versions. And this means that we will need to put this code in a separate file and then restore the same code as it was before for the older version. I would say that if we would be migrating new plugins, then we should do this for 24.2, and older version should has only K1 mode acceptable. And I think that we've mostly done. We will need to clean up code a little bit, but the plugin is already migrated.
Nice. I have a stupid question. Exactly this line where your cursor is and where you added this to list. So before adding it, you had this exception. How did you know that it's a sequence there and why sequence is not allowed?
The sequences are lazy collections, and that's why you can get the outside analysis session leak for this collection to some later point, and that's what happened. And we just saw that if you try to use the same analysis session from different points in the history, you can't leak anything because you would not be allowed to. But
so basically, we cannot return the instance of the session out of this block.
Yes, exactly.
All right. Cool. But what should the developers do who want to maintain just one version of the plugin for both for K1 and for K2?
If they want to support only latest versions, then this migration would work both for K1 and K2 because Analysis API hides this, and there is implementation for K2 and implementation for K1. In most cases, it works fine.
Mm-hmm. Okay. All right. Nice. Have you seen any other plugins? Have you tried migrating any other plugins to this new API?
Sure, we migrated Kotlin plugin itself.
Nice.
Some
How big was the effort?
we are still not done completely. There are a lot of inspections and intentions which are not migrated, and probably some refactorings as well, which are not highly used. But it's a great effort, and we are mostly doing this for the last couple of years.
I see. Well, K2 is enabled in the latest AIP, as far as I know. Like it's enabled by default. I guess there are some implications, and Dmitry is going to highlight those for us in his slides now, so we can switch back to Dmitry's slides, I think.
Yeah, it's just a quick summary. So to migrate to Key2 plugin, yeah, we made a task to run debug IDE with Key2 mod. We mark it plugin as compatible, and we will read E1 usages to the analysis API. And that's it.
I see. Well, I think we need to highlight one thing here is that what will happen if you don't migrate, right? What is going on there? If my plugin is not compatible with K2, what will happen in this
Yeah,
case?
in this case, a user who has K2 mod enabled will see a notification that your plugin has been disabled because it's incompatible. And here is two options. Option one, user have your plugins disabled, and other option, user change back to K1 mode and works with your plugin as usually.
Okay. Well, I hope that it will not be a big pain to migrate the plugins for the community. At least we have seen it's possible, and Anna has demonstrated that amazingly. So we don't really have questions in the chat right now, and I exhausted my pool of questions. So, folks who are on the stream, let us know if you need more information, if you can migrate your plugins, or if you need help. Of course, come to the Slack, ask questions, and the team is there to help. Otherwise, if you're watching the recording, also you can check out the description for the links. Don't forget to subscribe to the channel, of course, and ring the bell. And yeah, if you need help, again, come to the Slack channel. Yeah, we are done basically here, and thank you, Dmitry and Anna, for for this information. I think folks are going to be happy, and thanks for coming. Yeah, we have some comments in the chat. That's nice. And have a nice Kotlin, everybody.